from point A to B, which is 15 kilometers from A on a bearing of 0.4 degrees. The ship then sails to point C, which is 19 kilometers from B on a bearing of 130 degrees. The following diagram shows a sketch of the ship's journey. Okay, yeah, so they have a sketch of the ship's journey. Cruise. Now, not to fear, make nobody feel fearful, but with Baron's question, I believe most of you are paying attention, right? But with Baron's questions, I am telling you all, you need to be glued to the screen. Um, because from what I know from some students complain about Barons and some complain about vectors. So the thing with Barons is not that it's that difficult. The thing with it is you have to sometimes certain things that you are required to find, you have to work around the question. So, like for instance, if they tell you to find a bearing of one letter to another from another, or so on, angle and those things, you may not always get it directly by using one formula. You might have to use multiple rules before you can get it. So that's what makes it sometimes a little complicated. But apart from that, it's decent to me at least, right? So they said on the diagram, instead of the bearings 0.42 and 130 degrees. Okay. So let me zoom this down a little bit. Zoom it down. Right. So in order to know where to put those bearings, which are angles, and as you all can see, anytime a bearing is less than 100, you write it in 3 digits. Okay, so anytime a bearing is less than 100 degrees, you write it in 3 digits. So you have to include 0. So again, they said a ship sails from point A to B. Where's B? Which is 15 kilometers from A on a bearing of 0.45 degrees from A. Okay, so where A is, there are two bearings. Bearings are angles, right? How do we naturally normally calculate bearings? You always start north of the point, right? So we have the north cardinal point already. So from where A is, the north, we go clockwise. We always go clockwise from north. So if we go from here to here, this would be represent the bearing. This piece of angle represents the bearing. If it is, this is B. And that could be B. And starting again from north of A, if we try to calculate, there's another bearing that will go from north of A clockwise until here. That's if we need to find a bearing of this point. We'll go up to this line that connects to that point. So based on what they're telling us, I know you all, and you all should be able to know, right? Naturally, normally 90 degrees is around this. It can't be this other line because this angle looks a little bit greater than, slightly greater than 90 degrees. It's not exactly 90 degrees because the lines are not straight, right? This line is slant. It's not like perpendicular fully to the cardinal point, the north. So it can't be this point. This point cannot be B because this bearing or angle from north of A to the line that connects A to wherever this other point is almost a little bit greater than 90 degrees. So if they're telling us that, so in a question, I guess you'll have to kind of use common sense in a way. If they're telling you that A, point A, which is this point, right? A ship sails from A to B, which is 15 kilometers apart. So A and B are 15 kilometers apart. That part not really easy to figure out, but the bearing is what kind of gives it out. So that means B has to be here. B have to be there. It cannot be this point. And I just give you a reason why. So I hope you're paying attention. If anybody is unclear of why I label here as B, let me know what that has to be B. Because again, If we go from here to here, from north of A to the line that connects A to this other point, right? This other cardinal point here. This angle is actually smaller than 90 degrees, which means it will be anywhere around 42 degrees approximately, right? So this has to be 42 degrees. This other entire angle is too large to be 42 degrees, so that cannot be the bearing they're talking about. So B has to be this way. So we put 42 degrees here, 0.42, and the length or the distance between A and B is 15 kilometers. So again, if anybody is confused or lost, let me know please before I continue. Now, not all bearings questions you'll have to label, but this one here. Forgive, no questions. So they also said we need to insert the 130 degrees, right? So the ship then sails to point C. Whereas point C has to obviously be here. Because if this is B, this has to be C. Right? So it says it then sails to point C, which is 19. And if you look at the length between A and what I label as B, the side is naturally looking shorter than B to C. So B to C has to be longer in terms of the distance. On a bearing of 130 degrees. Now, how do we naturally calculate bearing? We starting from B. Now, you might be wondering, why are we starting from B? They said the ship then sails to C. So it sails to C from B, because that is where it was from what I read first, right? It said first again, a ship sails from A to B, and then it continues in other words and ship to C. Sail, sorry, to C. Okay? So, based on that information, if we calculate in bearing, you always start north of the point and you go clockwise. This angle, even what they told us is 130. If you look at it, it is greater than 90 degrees. Because the 90-degree mark would have been around, just estimating, right? We draw a straight line here, 90 degrees to be somewhere around here. Anything that exceeds this line is greater than 90 degrees. So yeah, that's what the 130 degrees is going to be, right? That's where the 130 degrees is going to be. I hope that is clear. If you have questions, make sure and ask them, okay? I know for 1 mark, this will have really taken some students to think on a whole deeper level, or you really had to know bearings to be able to do this question, okay? Um um so I'm going to scroll down to the next part. Let's calculate the distance between tongue A and tongue C. Tongue A and C. Okay. So tongue A is over here. Tongue C is over there. The distance they want is the line that connects A to C. So what do we use? So a few things I'll tell you about Barron's question, right? It is a question related to trigonometry. So certain things in geometry you'll need to know, such as the total degrees of um, a triangle, which I think you already know. You need to know what do you call this stuff again? Parallel lines and transversal. Sometimes that helps, but not necessarily for the length of a side though. Parallel lines and transversals help with when you need to find like an angle or bearing. So if it is I have to use it, which I may at some point in this class, I'll show you. But for this specific question here, We look at this triangle. This triangle does not have a 90 degrees. Normally, when you're doing a Barron's question, there's no 90 degrees involved. It's very rare to get a right angle triangle in a Barron's question. Hence, the formula that we have to use is either going to be the sine rule or the cosine rule. You all may remember, for those who were in class probably a month or two ago, I gave you all what I was going through actually a list of formulae you all need to use, right? So that's all we're going to have to use here, right? In order to use the sine rule to find a missing side such as AC, we either need, not either, we always need a full pair, right? A full pair means you must know the size of an angle. You must know the length of the side opposite the angle. And since we need to find AC, we need to know the angle opposite AC. When we look at this triangle, we don't know no angle, at least not yet. We may be able to figure out one or two, maybe, right? Actually, we would be able to figure out. But before I decide whether I'm using the sine rule or it's cosine rule, let me check and see if the cosine rule will work before I find an angle, if I can even find one, which I should be able to. So the cosine rule, to find a missing side, you must know the length of two sides and the angle between them. So either way, we need to find an angle to use the cosine rule or to use the sine rule. We need to find an angle. So if we know an angle, let's say it's 10 degrees, and we know the length of two sides, we can use the cosine rule to find the missing side. So it's either we need a full pair, opposite side and angle known, or we need the angle opposite AC specifically, because we already know the length of the sides here. We just need an angle between them to use this cosine rule. So here's where I need you all to keep glued and don't get distracted, okay? All right. So just now I was telling you all sometimes you need to know parallel lines and transversal, and here's where it comes in. So when you all are doing Barron's question, always extend the cardinal points. Well, not all the time, but based on what I'm going to do now, you need to extend them. But before I extend them, I want you all to bear in mind, I'm going to find this angle here, right? I'm trying to find this angle. And if you look outside here, if I figure out this angle, it'll be easy. You'll see a circular shape form here, right? So these three angles form an entire circle. And you all need to remember the total amount of degrees in a circle, okay? Which I hope you all remembered, right? So if it is I figure out this angle here, I could add it to this angle here, take it away from 360 degrees, which is the total amount of degrees in any circle. And I'll find this one. Now the question is, how do I find this angle? Well, I already see it, but I don't know if you all see what I'm seeing, okay? So that's where Barron's could be a little tricky. You need to have eyes to see, not normal eyes. You need to have mathematical eyes or something like that. So this North Pole, you can extend it in an exam paper. You can use pencil and stuff, right? Here we can extend this. To make this look less complex and confusing, I'll remove that. So these north, now what I have drawn is really a north-south, right? You don't even have to put in south, but that's what it is. We extended it into the south part of the cardinal points. And so we have north, south, and we have a transversal. A transversal is a line such as AB, but we need to extend it. We need to extend it. If you don't extend this, you may not be able to see what I'm seeing. So I'm still going to do a sketch out here so it's clearer. When you have a pair of parallel lines and a transversal, a couple types of angles are formed. The one that I need to use for this one is interior angles. Some people call it co-interior. Don't matter really, same thing. So we know this angle over here, right? That angle is 42 degrees. That was a bearing they gave us. If we find this angle, this one over here, we'll be able to figure out this angle over here. Now, how do we find this angle? Now, at least one of you was in my Thursday class, I believe, last year when I was doing, what was I doing? I was doing parallel lines and transversal. So I wonder if I please revise that over. Anyways, I'm not putting nobody in the spot, but just see. Interior angles add to 180 degrees. All these little things in math is so important to remember for those who actually did the topic, of course. Because if you don't remember, how would you do this stuff? Now, you could use calculator. It's a pity I didn't open a calculator, like, come on, it's a paper to goodness. So this is 7. This is 10 take away. 2 is 8. 7 take away 4 is 3. 1 take away nothing is 1. So we just found this angle to be 138. So we just got an angle, the angle that is vital to help me find one angle in the triangle. Okay. I remember I told you all just now, a circle has a total of 360 degrees Celsius. Well, it's not Celsius, but when you say degrees, sounds like Celsius you're talking about. So at this point, so the diagram doesn't look confusing, I will take off this. We don't need this anymore, at least not at this moment. Okay, so we will add 138. We will add 130 degrees. What would we get here? 8, 6, 2, 68. And then we take away from 360. Did anybody take it away as yet? And if you did, what did you get? Did anybody take it away? Oh, is it that everybody's sleeping? What's going on?
Mas again, 92 degrees.
92 degrees Celsius? Okay, that probably correct, I guess. Think so. I hope so. Did you double check it or you just checked it once? Because if that figure wrong, I start to work on this question, then I have to come back and fix it. So, did you double check it? Did anybody double check it? Just to confirm. Double checking saves marks, right? So yeah, why not double check the thing? So, okay. Okay. Okay, good. So that is 92. Thank you all very much. Wonderful. So 92 degrees. Finally. Now, to help you all not get confused because it has so much things going on the screen, I'm going to take all this, right? I hope you all have that. I'm going to take out some of the unnecessaries like this. I'm getting off, 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 off. Right off. Um, what was I going to do? Yeah, so we need to find AC, right? I'm going to draw a sketch. I already know I'm going to use the cosine rule. And if you're wondering why I'm going to use the cosine rule, well, we still don't have a full pair. Like we just found this, the length of, not the length, the size of this angle, but we don't know the side opposite. In fact, they want us to figure out the side opposite. So we don't have a full pair where opposite side and angle is known. Here we know the length of the side, we don't know the angle. Something missing. Here, same thing. We know the length of the side, we don't know the opposite angle. We don't have a full pair, and also we cannot use the sine rule. Hence, it is the cosine. And to confirm it is cosine, we have 92 degrees. We just found that. We have 15 kilometers, we have 19 kilometers, okay? To use the cosine rule to find a missing side, you must know the length of the two other sides of the triangle and the angle that is in the middle or between the two sides. And we do know 92 degrees is between 15 kilometers and 19 kilometers. Hence, it is the cosine rule. So the cosine rule that I like to use is c squared is equal to a squared plus b squared. A squared plus b squared minus, I almost forget this formula, what is the rest of this? Minus 2ab. I feel like ages I've used this formula. Cos C. Yeah, my brain started to do a little bit of some kind of thing just now there. All right. Some people use it as a squared is equal to like whatever you're accustomed using it as, just use it. Um, okay. So um, we need to label some stuff here, right? I'm using the sketch diagram because if I label the main diagram, you might get confused. I don't know what going on with that stuff. Um, so we have C. C is okay. Common letters are sides, right? Capital letters is normally an angle. So the C is by itself represents the side you need to find. Okay. The other two sides, it don't matter which one you leave as A and B. Um, but because we have to add them, right? And I think I've told you all before, if you all remember in different sessions, when you add in the numbers, it's commutative, so it doesn't matter if you put 15 before 19 or 19 before 15. You still get the same thing. Even though they have to be squared, you still have to add them. So it's not going to change anything, so it don't matter which side of the other two sides you label as A or B, right? Um, what else? Capital C is the angle. Capital C is the angle between the two sides. Yeah. Um, um, I thought I saw someone sent a message. Am I seeing things? All right. Thought one of you sent a message. I don't know what happened there. So we changing the information. We can leave this as c squared or you could change it as ac squared, right? Is equal to a is what, 15? So we put in 15. Don't forget about the squared. B is 19. Don't forget to put the squared. Minus 2 multiplied by the same A is 15 again. B is 19. Um, cos C is well, C is 92 degrees, right? Okay, I need to put a line here because this kind of, yeah, yeah, we don't want to get too confused, okay? Um, okay. Um, you'll just give me a few seconds, please. And thank you. Okay, sorry about that. Okay, so we could use the calculator. The good thing about this, Come on, guys. That's why you want to make sure, sorry, that's why you want to make sure and work with your calculator, scientific calculator for math paper too. Because you don't want to work without that. Because to continue working this manually, you can work on the cost part, but you can work on everything else manually. I'm just taking off this temporarily because it's blocking the calculator. Too many things are blocking the calculator. Okay. So we taken whenever you have a question and you have to enter cos and sine or tan and stuff, you have to make sure the calculator is on degrees. Okay. So make sure it's on degrees. This one's on degrees because you see in it blue. In yours calculator, like a scientific, in the top, you must see DEG. If you see DEG, it's on degrees. If you see RAD, it's not on the correct thing. You need to reset it. It's on rad or something. So we're going to put in 15 squared. Don't start. Don't start. Not again. Okay. 15 to the power 2 and 19 to the power of 2. Take away 2. Multiply by 15. Multiply by 19. Multiply by cos 92. Yeah, let's double check it. 15 squared, 19 squared. Okay. Yeah, everything seems to be perfect though. So I got there, what did I get? 605. That's what I'll get, but that's not the final answer. Let me undo first so I could get back what I had on the screen before. Because if I don't undo now and I write, I would be able to undo nothing. Okay, so it's c squared is equal, I'm going to write it as, this is less than 5, so we don't add anything else, so it will be 605. But that's not the final answer. Does anybody know what we need to do next? Can somebody tell me what we need to do next?
Yeah, to find the square root of the answer to get in kilometers squared.
Yes, because it's in a power, so we need to get rid of the power. Thank you so much. You can't leave the answer with a power. That's not the final answer. So we find the square root on both sides actually. This will remove the power of 2, leaving us with c is equal to. Okay, I apologize that my screen has so much going on. For the next question, I'll just rearrange my screen, okay? Um, hopefully I don't forget. I shouldn't forget actually. So 605.89. 89. Okay. So I got there 24.6. I don't think they said to do anything I could wrong. They probably said in there its whole number. 6 is 5 or more. We need to add 1. So I'm writing it as 25. The other side's in kilometers, so that'll be in kilometer. And that makes so much sense, you all, to me visually, because if you look at this diagram, right, this side seems to be the shortest, this side is a little longer, this side seems to be the longest. So yeah, we should get a longer kilometer for sure. So that's the answer for that part there. You also, what I told you all before, if you all were listening, right? With Barron's questions, it's not always straightforward. We needed to find AC, but what did I have to do? I had to use parallel lines, which is the north cardinal point, extend them, the line connected between them, extend that to use interior angles, then use angles in a circle, then use cosine rule to find one thing. Well, for 2 marks, right? I don't know what CXC girls be doing now. They're so stingy with their marks. Stingy. You got 24 point. Yeah, you could leave it like that too. It's not area we finding, eh? So take off that squared. And it's not cm, it's kilometers because the other sides are in kilometers. Make sure you put the correct metric unit. Okay? That's okay. That's why I'm here, okay? So you don't make that error in your exam. You are getting the opportunity now to make your corrections, okay? So I hope everybody's good. If anybody's writing, let me know before. Just now, hold on. Is there another part in this one? Yeah, we still have to do with that part. Is there another part? Okay, no. We have one more part to do here. One more for this question. It says determine the bearing of tongue E. Excuse me. I'm taking off the working, right? Because nobody's indicated that they are writing. But as I just say from time to time when you're doing any questions that has to do with measurements or diagrams like these and stuff, whenever you find an angle, put it in the diagram. Whenever you find a side, put it in the diagram, especially when the question has multiple parts. Because if you just put it in the answer space and you don't put it on a diagram, then you have to find something else and your diagram looking as it was looking originally. Then you'll be like, you might forget what you found before and you might not realize what you found before was supposed to help you to find what you trying to find next. That's why it has multiple parts, right? Normally what you find previously does help you to find what you need to find next. One is the same question, another part. So part three here says determine the bearing of tongue A from tongue C. Tongue A from C. So we starting from C to find the bearing, north of C to find the bearing to tongue A. Right? So whatever they said after from tongue C, that's where you starting from. So from C to A. C to A. So let's do that. Okay. C to A. C is over here. A is over here. They said from C to A, right? The bearing of tongue A to C. Let me just double check so I make sure I find the correct thing. Because it's two different bearings, you know. The bearing of tongue A from C. Good. So we starting from C. Just have to make sure. Because if I start from A, I could find a bearing towards not the correct one they asking for. So C, we started north of C. No matter what point you're starting from, you always check the bearing north. Some questions you will not see this north line drawn. You have to draw it yourself. These have it drawn. So you start north and you always rotate clockwise from north of the point until you reach the line that connects A to C. The line that connects A to C is this line. This line we just found the length of. So we're going from here, north of C, all the way to here. We need to find this entire angle, and that will be the bearing of tongue A from C. Okay, so in order for us to figure out, we don't have no angles around here. So we need to find two angles, and then we'll be able to figure it out. We need to find this angle here, and we need to find this angle here. Once again, it's going to be a work around the clock. Welcome to the Will of Beering. Work, working, working, working. Um, all right, so which one should I find first? It doesn't matter which one I find first, but mm, let me see. The easier one to find first seems to be this one. And the reason why I said that because I already know this angle here. And if you all don't get where I'm coming from, it's the same thing I did just now. The same thing I did. I'll do this again so you all can see once again. Okay. So extending, oh goodness, let me use a thicker line. Okay. Extending the north, south, extending. Then we have the transversal. If I do it separate, it looks more cleaner, okay? Too much is going on there. So we have 130 degrees that they told us to label before. If we need to find this angle, that's the same angle over here. They are interior. Both of them are within. So the interior, right? When I say within the north-south. So let me see. I think somebody was paying attention. Very good. So yeah, because I was like, at least you have some people paying attention. I think all of you paying attention, but I will only know if you send me stuff via the chat. Like, if you don't send me anything in the chat, most likely you still definitely paying attention, but I can't see for sure. So yes, all you have to do is take 180 degrees, take away the 130. These two angles must sum to 180. So that's why I said I think this was the easiest one to find. Easiest, easiest, easiest. Now, another thing before I continue, right? If you have noticed, right? In this diagram, the interior angles is within a shape like this. So you don't if you get so accustomed with bearings question, you don't even have to extend those lines. Like I don't have to extend those lines, but I'm just extending for you to see clearly, okay? Um, and you could just simply look at from here to there, and these two angles within here, and this one there, they are also 180. So, but you could do the full extension or you could do a partial, whatever works for you, okay? So we need to find one more angle. When we find that next angle over here, it will be so easy to figure out the bearing of E from C. Let's go. Okay, so how do we find this now? Look, we have to look at the triangle. Examine the triangle. See what you know. Okay, anytime you need to find an angle within a triangle, you kind of use the parallel lines. I mean, sometimes you could have, but it's not really the best option. The parallel lines work best when you find the angles outside the triangle, like this one, or that one, or that one, or that one sometimes. But when it is you find an angle inside the triangle, is normally you're using the total degrees in a triangle. So if we knew this angle here, if we knew the size of this angle, we could have added it to 92 and take it away from 180 and we figure it out. We don't know another angle, so the only other option is sine rule or cosine rule. Now, when do you use the sine rule to find a missing angle? You need a full pair. We have a full pair, y'all. Are you seeing what I'm seeing? We have a full pair. The full pair is we know the length of this side and we know the angle opposite this because we found those previously. You all see why I said just now, when you are doing these questions, yes, write your answer in the answer space. However, also put those angles and lengths on the diagram because you will need it when the question has multiple parts. Had I not put this here, I might have been thinking, huh, how could I find it? And I don't find that before already. How could I find this one? I don't find it before. Like, no, you don't want to be stressing yourself in a math exam. So reduce the stress by doing yourself a favor, writing what you found in pencil on the diagram also. So we have 92, we have 25, that is a full pair, opposite side and angle known. And we need, in order to find this angle over here, we need to know its length. And we do. The length of the angle is 15 kilometers per hour. Okay, it's not a time graph question, but you know, just say when we say kilometers, we don't know about traveling or speed or something, okay? Anyways, so we could use the sine rule for this one because we have the full pair and we have a half pair. Half pair means for the angle you need to find, you must know its opposite, the length of the side opposite it. So, sine rule. Let me just take off this from here because I need some spaces. You know, I told you all just now, right? But anyhow, that would not have worked out anyways. I'll do it for the next question. So the sine rule, some people just put side over angle. I go with side over angle, or you could put angle over side. It doesn't matter, you know. The two formula are the same thing really, just the flip way of it. Okay, so this is a sine rule partially, and you normally just need two parts, right? Um, okay. Um, the full pair, I normally like to put the full one, the first one as the full pair, right? Always remember your common letters is a side. Capital letter is an angle. So for the full pair, the side 25 kilometers is common E. The angle 92 degrees is sine of A. So we put in 25 for the side divided by sine uh 92. A is 92 to replace capital A with 92. So that's equal to B is this other side for the half base. So that's a 15 kilometers. And sine B, that's what we're trying to find, right? We're trying to find an angle. So that will remain as sine B. Now, just like any other question, you could do one or two things. You can either fully transpose and get B by itself, or you could cross multiply, but you still have to transpose at some point. So I'll cross multiply, okay? So we're going with sine 92 multiplied by 15 is equal to 25 by sine B. You know, I now think right normally I like to put what I try to find on the left hand side, but I mean it don't really matter, you know, so I can leave it right there anyways. Okay, next thing to do, we still have to get B by itself. We need to get B backed by itself. So we need to remove two things. We need to move the 25 and the sine. Both of them are being multiplied, but we have to be careful here, right? Because it's a trigonometry type thing we're doing. So we need to move the 25 first, divide them both side by 25. Okay, divide here by 25, divide here by 25 because it's originally being multiplied. This will cancel, right? So we remain with sine B. Sine B. Now, some students will go and work this out. I tell you, if you work this out right now, you get some kind of long decimal. And I'm not going to write on that, so leaving this just as it is for now. I'm so sorry. This is so close. I'm probably looking confusing. Let me space it out a little bit, a little bit. Sine 92 by 15 divided by 25. The last thing we need to do is to move the sine from the B. The process, you all don't need to know the full process. It's not that complicated, but you all don't need to know all of that. All you need to know, anytime you move sine, cos, or tan from one side of an equal sign to the other side, it becomes the inverse. So currently, this is sine to the power 1. Currently, when you don't say a power, it's to the power 1. So when you move it across an equal sign, it becomes sine to the negative 1, which is sine inverse. And that's what you needed to become in order to find the angle. Otherwise, you wouldn't find the angle if it's not sine inverse, the inverse of sine. So I'm going to rewrite it like this, right? I'm switching it around, putting the b by itself. And on the other side, we put it as sine inverse, sine to the negative 1 power. Open brackets, we have sine. Well, some people they say sin, but I say sin though. it looks like it's spelled sin because it's in short form, but the real word is actually sine. 15. I am so sorry, y'all. I know this thing looking a little bit, So I have here sine 92 multiplied by 15 divided by 25. At this point, y'all, because we don't have any more questions to do for this one, I am clear on the screen because, yeah, it's too much stuff is on the screen. Okay, so in your calculator, again, make sure it's always on DEG degrees. And we're going to press inverse or second function, second F, sine. It will either come up as sine to -1, arc sine, or a sine. Then you will put, well, in this case, I need to use a double bracket to put in the numerator. So sine 92. What is this? Sorry about that. Sine 92, I don't know. Just so multiply by 15 divided by 25. Okay, I think I need another bracket or I have enough brackets. So we have this already bracketed, then we have this bracket for the numerator. So we have this for the numerator and then the third pair of bracket for the full thing. Okay, so it's good. I got 36.84. I don't know if anybody has worked it out. Did you all get the same thing, different thing? Please tell me. What did you get? Did you get something close? Close enough? Far away? Far away? Oh, you don't know what to do. Well, I mean, the question's on the screen, so um, I'm writing my answers to the nearest whole numbers. 8 is 5 or more, so I add 1 to the 6, it becomes the final answer. Angle B. Well, this is not the final answer. This is the answer. What am I writing? Sorry. This is the answer for I now realize what happened here. I now realize I thought it's not funny, but I have to laugh because I really thinking I finished this question. This question not finished. Because what I found was this angle here. Lord, put a hand. Okay, you all need to help me, right? Because now just now we now found 37 degrees, right? Which was this here. I forgot clean is the bearing we trying to find here, right? What did we find here? I think it was 50 degrees, I think, because it had 130 was above here. I remember that. If I put in anything wrong, you'll just let me know. But I just trying to remember what I saw. I don't need nothing else really because it's the bearing we need to find here. You'll see, even I have to be on my P's and Q's. Because I was like, we finished the questions. I started to erase thing not to undo it. But lo and behold, I have one more thing to do, or two. So now we have to take 37 degrees and add 50. Lord have mercy. That is going to give us 87 degrees or so. Taking that away from 360. What is the answer, y'all? Please help me out here. What is 360 take away? 87, please. What is it?
272, miss.
What did I get? 273? That's what I think I heard. Is that what you said?
Yeah, miss.
Thank you very much. Okay, I don't think nobody got anything different, but that will be the bearing of tongue A from C. So that's here, 273. Yeah, you all. So this question help you all to learn a few things, right? Even though it's a bearing question, you all know how to use the sine rule, well, at least somewhat, and the cosine rule. Because sine rule and cosine rule are not only using bearings, any triangular question where they may ask you to find a side or an angle and it's not a 90-degree and it doesn't have 90 degrees, it's sine rule or cosine rule you have to use. Okay, so just keep that in mind. So I'm going to clear the screen. If anybody have questions, let me know. If not, we're going to do another one.